Hi there, this is Lemon Lattice, and today we're going to be looking at nozzle sizes and flow rate, and specifically flow rate calibration, and figuring out how much material your printer can melt and extrude to create your 3D printed part as clean and as fast as possible. So your flow rate is going to be a measure of how much material your 3D printer can melt and extrude, and that's going to be in terms of millimeters cubed per second. So the millimeters cubed comes from layer height in millimeters times line width or perimeter width in millimeters. We're going to use perimeter width because we're working with Super Slicer and that's what they call it. And then our third one is speed, which is in millimeters per second. So we've got layer height times perimeter width times speed, and that's going to give you your flow rate. So once you find your maximum flow rate, you can then change any of those three parameters and maintain a printing speed that you know is your fastest way to get a good, clean print. Before we talk about how to do a flow rate calibration, we need to talk a little bit about nozzles. So nozzles come in different types and different sizes. The different types could be things like what the material is. It could be a brass nozzle or hardened steel. It could be plated copper. And then there's also the different types as far as like an MK6 nozzle or a volcano nozzle. These are different brands and different types that are made to work with different things, like the E3D V6 versus the E3D Volcano. And that's the size of the heater block, and the nozzle has to be the same size to fit into that heater block. So the Volcano nozzle, for example, is longer than the V6 nozzles, and that gives it a bigger melt zone to help increase your flow rate by giving you more time to melt your material so you can push more of it faster. There's other nozzles like the Bondtech CHT, which comes in multiple sizes, but it has an internal geometry that even more effectively melts material. And I personally use the 1.8 millimeter CHT to get as much flow rate as possible. Now the other thing I do is pair that with a CNC Kitchen adapter. It's a volcano adapter for the Bondtech CHT nozzle. So I recommend you check out CNC Kitchen's YouTube channel and his website. He really goes into the science of 3D printing and helps explain flow rates and extrusion and all of these different topics in great detail. And I've really learned a lot myself from watching him, so check his out if you want a more in-depth explanation of any of this. Whereas I'm going to mostly focus on how to calibrate this for specifically prosthetic printing today. So there's the different diameter of the nozzle openings, and then the other part that's important is the actual flat spot on the end of the nozzle, which in some part dictates how wide of a line you can print. When extruding, you don't want the width of your line to be more than the width of that flat spot on the nozzle, or you won't get good control of your extrusion to smash it into the layer below it. So you also want to make sure that your layer height isn't too tall for your nozzle diameter. Most people say not to go over about 3/4, so 75% of your nozzle diameter should be your max layer height. As far as line width, I like to go about 1.25 to 1.5 times my nozzle diameter because I feel like that gives me a good combination of fast printing but also clean printing and strong printing. Moving on to the actual calibration, first we need a shape. So we're going to import a plane in Mesh Mixer, and that's just to get started, and then you can Mesh Mix onto that and bring in the cube shape. I like to do mine 50 millimeters by 50 millimeters by 25 millimeters, and then you can orient that however you want. So it doesn't really matter which one is which here. You'll set that up in Super Slicer. So create your shape, then you can delete your plane, After you turn on your object browser, you can select that, delete the plane, and then you have the shape you want to export and take that to Super Slicer to start your calibration. So we load this shape into Super Slicer and orient it with the 25mm in the Z height. I'll take you through the settings here. We're going to do 2 perimeters, 0 top layers and 3 bottom layers. This will be for a 3mm thick socket that I would use for a typical flexible inner prosthetic socket. We have 0.5mm layer height. We have no infill. All we're trying to do is print some walls here so that we can measure them. And you can see all the other settings we're using. I'm doing 1 skirt loop, no support material. Our speed, we're going to start at 25mm per second, which I know was good for most TPUs. Sometimes you can go faster. We're doing 1.5mm on the spacing. The width is a little larger. And you can see that the help and details drop down there will tell you why we do it for the spacing. It's to end up with a perfect 3mm. And that's all for the print settings. Going to filament settings, we're going to start with an extrusion multiplier of 1 and nozzle temperature of 220 and bed temperature of 60 degrees Celsius. Shrinkage, we put 99. We know this is going to shrink just a little bit as it cools. We're doing 50 on our cooling fan. And these are just things that I know work for Yoyi brand TPU over time. Our retraction length is 2mm with a direct drive extruder. And moving to our printer settings, this isn't the actual nozzle. We're using a 1.0mm nozzle, but make sure you have that minimum extrusion length set to 0.5 and not 0.035 like the default is. And then you can see my custom start G code where I took out the bed leveling because we don't want to do that at the beginning of every one of these prints. We're going to run a handful of these and we don't want to waste time on that. And then you can just see the other settings. So stop and pause the video if you need to get these to set up to use TPU. Now your brand might be slightly different depending on what you're using, but this is what the shape should look like once you get those settings, and this is what we'll use for the calibration. So check that, and then you can export that, and we are ready to print. Now there are several things we're looking for. It's not just the thickness of the walls. We're actually also looking at the base layers, and those are going to be our first sign of how things are going. So this is 1.5mm width, 0.5mm layer height, and a speed of 25mm per second for a flow rate of 18.75 millimeters cubed per second. And I could see right away that these lines weren't connecting well. They weren't thick enough, which tells me that something with my settings is not right, that I'm not getting proper extrusion for that flow rate. You can see the gaps between them here. So we know that 220 degrees Celsius and an extrusion multiplier of 1.0 is not going to be proper settings for this level of flow rate. So while we would normally only change one setting at a time, this one was pretty far off. So a quick calculation to verify that flow rate again, and then we're actually going to increase both the temperature and the extrusion multiplier to get started because we weren't where we needed to be. So we're going to go from 220 up to 230 degrees Celsius on the nozzle temperature, and we're going to take that extrusion multiplier from 1.0 up to 1.1, and then we're going to run the test again and see what that looks like. So right from the start, I could tell this one was looking better. These lines were closer together, and it was enough that I was comfortable letting this one run a little bit so that I could measure some of that wall height as well. You can see we're still not connecting there, but we had enough to actually see what that thickness was, and we were at 2.78 and we wanted 3 millimeters. So we need to make some more changes. We're going to go from 230 degrees up to 240 degrees Celsius, which is getting near the high end of the TPU range. And we're going to run that one more time. This print looked pretty good, so I felt comfortable letting this one run to the end without feeling like I was wasting material or time, so that I could get a full look at what it was going to be. The print quality looked excellent. I was really happy with how that one ran, but looking down in it again, we can see there's still just a little bit of gap. And then taking our measurements, we're just a hair under 3 millimeters still. So I'm taking those measurements at this center point of each of these walls and just trying to grab the top couple layers or top couple millimeters. We don't want to go across the whole surface of the print, or we might introduce some variation. But we're just a little bit off, so there's a couple options we have now of how we want to address this from here. We were at 240C and an extrusion multiplier of 1.1. So I actually decided to do 2 tests, and I'm going to bump each of those up independently a little bit and see where we get to. So 250C with a 1.1 extrusion multiplier and 240C with a 1.15 extrusion multiplier both gave me prints I was very happy with at an 18.75 millimeters cubed per second flow rate. Measuring my walls, I had some measurements that were just over and some that were just under 3 millimeters, and that's exactly what I'm looking for. You're never going to be perfect. There's going to be variation. So as long as you are within that 0.1, you have a very nice print. The next step is to see just how fast we can print a flexible inner socket by changing our flow rate and increasing that. So I wanted to go all the way up to a flow rate of 30 millimeters cubed per second, which is a speed of 40 millimeters per second, while maintaining a layer height of 0.5 and a width of 1.5. So at this point, I want to talk about why sometimes we pick temperature and why sometimes we pick extrusion multiplier, both as ways to help increase that total flow rate. When looking at temperature, some of that comes down to the material. If your material doesn't do well at higher temperature, you might actually start to degrade the material properties if you try to print it too hot. You could actually start to kind of boil it off in a way. On the other side, extrusion multiplier is going to come down to your design and how you plan to print and what you plan to print. So if you're printing a prosthetic socket that is 3 millimeters thick the whole way through, and you know you just need that high flow rate so that you can print that at the best speed possible for the best print time possible, then you can go ahead and set that extrusion multiplier higher without any issues. But if you're going to have parts of your print, maybe you're doing some other type of printing or something more complicated where not all of your lines within that print require that high flow rate, then if you use that high extrusion multiplier, you're actually going to end up over extruding other parts of your print potentially. So we went all the way up to 30 millimeters cubed per second on our flow rate. The reason I wanted to try and figure out the settings for 30 millimeters cubed per second is that that has been shown to be the high end of what you can really realistically get out of a volcano nozzle and a volcano heater block. So that's what the Sidewinder X2 comes with, is a volcano style. So that's why I wanted to go all the way up to 30. Now, other things like the Bondtech CHT nozzle we talked about, when I've put that in this printer with the volcano adapter, I've actually been able to get up to 42 millimeters cubed per second. So that's a significantly higher flow rate, which has allowed me to decrease my print times and make my prosthetic sockets much faster. So you always have to figure out what is your limiting factor with how fast you can print. In this case, we took our print speed up to 40 millimeters per second. I'm not really comfortable going faster than that with TPU, especially this brand of TPU, because that's where quality starts to decline. So other things you could do to increase your flow rate and print sockets faster while not going over 40 millimeters per second on your speed would be to maybe increase your layer height. If we know we want to keep that at 1.5 millimeter width times 2 perimeters to get the 3 millimeter socket, you could try and up your layer height while maintaining your speed to actually get a higher flow rate and print sockets faster. You could also look at it and say with that 1.8 millimeter CHT nozzle, the flat end on that nozzle is a full 3 millimeters thick. So that opens up opportunities to look at, can you print with a single perimeter, and how fast could you do that going all the way up to that 42 millimeters cubed level. So check back with us soon. We're going to have that craftsmanship course coming out in the next probably week or two here. And we'll look at all of these things and we'll really dive into how fast and how clean can we print with PETG, but also getting into TPU. So thanks for watching today, and we'll see you next time.